Okay, I'd now like to turn things over to Gil Amdurski from Toronto and Region Conservation to share some information on their STEP program. Hi, Gil.
Hello, can everybody hear me all right?
Yes.
All right, good. I'm going to present.
Great.
And this always just takes so long because I always have a million things open.
I hear you.
There it is. I think that's it.
There we go.
Right, is
Perfect.
that full screen?
Yep, full screen.
Yeah, okay, good. So, yeah, I'm going to go through slides rather quickly. For those of you who don't know me, my name is Gil Amdurski. I work out of the STEP program, Sustainable Technologies Evaluation Program. That's under the TRCA, Toronto and Region Conservation Authority. So today we're going to do a quick introduction on STEP. We're going to talk very specifically about one project that we completed quite a number of years now, but still very relevant to this topic, which is a review of renewable energy investments in the social housing sector. And I also want to talk about a few other relevant STEP projects relevant to this topic today. And then hopefully we'll have some time for the Q&A. For those of you just asking questions, this is a normal sized cup of coffee. It's just the camera does tricks here. So if you guys have any concerns about that, it's normal sized, I promise. So the STEP program, we are a nonprofit, very collaborative research-based group, again, out of the Toronto and Region Conservation Authority. Historically, we evaluated and researched a myriad of water technologies. So actually our group is split into two, water and energy. So the water side is actually much larger, and they do research projects, LAD and training, again, around low impact development, stormwater, different types of stormwater and infrastructure, catch basins, bioswales, all that type of stuff. But I'm on the energy side. So on the energy side, we're very much focused on measurement and verification, pilots, kind of real world installations, and also evaluating different types of technologies, both on the technical and the policy side. The picture I have on the slide here is the Archetype Sustainable House. For those of you who aren't aware of it, it's in Woodbridge, very close to Canada's Wonderland, for those of you who know that kind of landmark. And we've been using it for the past 10 years or so as kind of our living laboratory, doing some real world testing on the small scale residential side. Some of our partners, sponsors, and funders that we've had in the past and currently, this list is much larger than that. Not here to boast, but just to show you kind of the breadth of the relationships that we have and the type of work that we do. So today, I want to focus, most of my slides are focused on this project, and it's a bit of a mouthful. It's called the Review of Effectiveness of Investments in Renewable Energy for Social and Affordable Housing. So, sorry, I have notes on a different computer for some reason. Not too many for this slide. So the main objectives of this program was to evaluate the impact of renewable energy investments, assess technical strengths and the weaknesses of those different technologies, identify success factors and KPIs, and assess the challenges and identify the strategies for addressing them. So this project was conducted in partnership with Evergreen through a CityWorks initiative. And it was also sponsored by, at the time, the MMAH. I think they're still called MMAH. And just a bit of a caveat. I know a lot of the different topics addressed a financial analysis. That's not going to be the top of mind for this discussion, simply because there's a lot of nuance and a lot of details to this that I mean, the project ended in 2018. This review did, and so I don't want to give those numbers because they may not be current till today. But there's still a lot of really good lessons learned. So just a bit of a background on what we reviewed. So we did a review of this program, the REI, which was a combination of provincial and federal funding into renewable energy. This was at the time of a whole bunch of other kind of stimulus packages going out, Green Energy Act, and so on and so forth. So a lot of investments in these types of systems were happening. This is very specific to social housing providers. And so they basically had this open call of, here you go, guys, you can have a system up to X $1 million. Don't remember what it was today. But you can invest it in solar PV, solar domestic hot water, or solar thermal, some people call it, solar air heating, geothermal, and small wind. So housing providers from all of Ontario were invited to participate, and 161 different providers did participate in this program. And so, yeah, the majority of systems were installed around 2009, 2010, kind of late 2010. And so we started this review process in and around 2016. And so the systems had already, 4, 5, 6, almost on the cusp of 7 years of operation. So there was a whole bunch of different systems that were funded by this REI, Renewable Energy Initiative, 360 in total. 1 second. So a lot of net lifetime benefits. So I mentioned before that it was roughly $57 million that was invested. Something out of the way. Sorry. But a total of 70 million in net benefits was delivered. So here you can kind of see, there's a lot going on in this table, but a lot of kind of non-energy benefits were also calculated here. So you can see that in kind of the fourth line down, benefits over funding, as well as the last line, the job creation. So how many full-time jobs were created. And again, I think the thinking behind the design of this program was very much stimulus. And so another thing to note, again, looking at that benefits over funding, kind of gives you an idea of how far your investment dollars will go. And again, there's some nuance here because of the funding that was provided. It was 100% free capital, but at the time, the feed-in tariff was actually quite huge, but also the price of PV was rather large. So that's why you see those benefits over funding. You get really good numbers for PV. Second here. So in terms of data collection, kind of how we went about evaluating these systems. So 31 formal interviews were conducted with a range of program stakeholders. This included service managers. So this is actually regional managers of social housing providers, the housing providers themselves, actual vendors of systems, the ministry program staff as well. In addition, a survey was designed in SurveyMonkey. 69 housing providers were emailed, and I believe we got responses. I think it was about 19 responses, something like that. Sorry, trying to look through my notes. As well, in-person site visits were also conducted. So this was actually really important to actually see kind of the status of some of these systems, especially ones that we knew kind of needed a bunch of O&M essentially. So like the typical carpets are solar domestic hot water, solar air, and then maybe much lower down the list is geothermal. So we received a lot of really good anecdotal kind of evidence throughout these interviews that we did. Some interviews we did were at, kind of like a provider level or service area manager level, very high level about kind of what other providers thought of it. And some were kind of boots on the ground, the actual operators of the system. So, we went to go visit systems in Mississauga, in Halliburton, in Newmarket, in Vaughan, as well as in Georgina as well. And so here you can see very briefly, I mean, I'm not going to read all these, but, some of them note, high O&M costs for different types of systems. Other note, just the ease of use and how it's been able to provide them some capital, like from the feed-in tariffs. So based on the survey interviews and the site visits, 10 housing provider case studies were also compiled within this research project. So the case studies documented reported system performance, provider experience with the REI administration, and implementation of their retrofits. So the basic criteria for selecting case studies was that the provider participated in a survey and noted that they were interested in a case study. Further, case studies were selected to ensure that across all case studies, there were geographic diversity and diversity in the type of ownership, public or private. Diversity in the technology type as well, and a high quality of feedback. Just very quickly, when I started, I think I'm just past the 10-minute mark. So I only have a couple more minutes. Again, so the key impacts are quantified in the table here. So the REI program really didn't place any limitations or criteria on the format or content of feasibility studies. And so we found there was like quite a range of the system costs that were provided. Proposed system costs didn't appear to be benchmarked against industry norms. So this potentially created incentives to overpay for some systems. There were some reports specifically that solar domestic hot water systems, certain systems or components were oversized or otherwise not optimally designed. Oopsies. PV and solar air were reported to require minimal operation and maintenance effort. Geothermal systems typically required less O&M than conventional systems, although some providers still opted for a maintenance contract. And again, solar domestic hot water systems were identified as requiring the most amount of operation and maintenance. And failures or suboptimal operation related to design or insufficient O&M were identified in several instances of these solar domestic hot water systems. PV systems were often installed with online monitoring gateways. I know nowadays they all are, but 12 years ago it was a bit of a different story. And yeah, I think that is it. So this is my last slide on the REI, and I'll just talk a bit anecdotally about participating in that project and going to some of those site visits. Kind of the more mechanically extensive and complicated the system was, the more issues we had with O&M or with system design or just operation in general. Typically, we found that the overall majority of PV systems were just operating with no issues. I think there was only one case where we went to a site and we found kind of one string missing out of like a giant system that kind of nobody else would have found out kind of for perpetuity of the system, if not for our site visit, because they didn't have an O&M contract in place and they didn't have monitoring. But when it comes to things like, solar air, even though the technology is rather simple, however, it needs kind of the certain place to be effective and to be cost effective too. So like for one is the building needs to have a ventilation system. I know most buildings do, but a centralized ventilation system, multi-residential, and in this case it fit because we were talking about social housing. And where it really fits is when the building needs to have a recladding anyways, because it essentially is a cladded surface. And so it does a really good job of lowering the ROI if the building needs to be recladded. Geo, we did evaluate some geosystems. There was some issues with some providers, but I think it was like a site and a capacity issue more than anything. Quite often, some providers had only a small handful of buildings, and they would just have each individual site super take care of that building. The problem is now, you have one person that is the same person that's in charge of getting, broken toilet calls. He's the same guy that needs to have a needs to have a look at $250,000 or $500,000 geosystem. So quite often capacity issues was the case. Another lesson was with O&M contracts is that some of the actual consultants went out of business. And so the O&M contract, even if it was, for 5 years or for 10 years, kind of didn't really help when the consultant went out of business. So that's kind of the main conclusions for that particular project, that review of social housing. I want to very quickly just mention a few other projects that are relevant to this topic. So one is a case study that we did of ductless heat pump retrofits in a row home. So this was social housing. We actually went in, we worked with Mitsubishi and Daikin to install a number of these kind of multi-split units. And then we evaluated their performance. We actually put in individual temperature sensors and power monitoring sensors before the retrofit and after the retrofit, and monitored the site for a period of a year. Tenants were very positive about the heat pumps. However, the financial business case was not strong. Some of these units had multi-head heat pumps, and the kind of price adder between a single split and a multi-head heat pump is quite great. There's a massive difference there. Again, I'm going to go through these rather quickly. Sorry, but there's a lot of relevant kind of information. I'm providing some links a bit later on. You guys could check out some of these reports. So this is a gas absorption heat pump project that we did. May not be too relevant for this group because we're talking about renewables, but just putting it in there because it does have a benefit of reducing GHGs compared to natural gas. Little benefit on the space heating side, but more carbon savings for domestic hot water, especially in a kind of commercial or multi-res application, because the bigger the load, essentially, and the more it gets used, the better savings it could produce. And then the last one, which is it's quite relevant actually to this project. And oh no, my notes are somewhere else. I'll try to speak off the cuff. One of our analysts, Eric Jansen, he actually compiled this study. Basically, we worked with City of Toronto, and what they found was that quite often when they would go out to do a geothermal feasibility is they would get like a myriad of kind of RFP responses with kind of a wide variety of scope of work and tasks and as well as costs. And so they were having trouble with that, especially with some consultants providing kind of low quality assessments or low quality kind of sizing and modeling. And so we helped them put together this feasibility assessment as kind of a guidance to prospective system owners to kind of say, okay, well, these are the check boxes that you need to put into your RFPs. This is the scope of work that the consultants need to go through in order to submit these RFPs. So, the biggest thing is to have a very accurate sizing calculation because, the difference between an oversized system, because many people have a tendency to oversize, but it could greatly impact the cost of the system and hence kind of the lifetime financial calculations. So this is on our website, and just very quickly, just talking about kind of some other things we do. I mentioned the Archetype Sustainable House. We also have a bunch of other kind of living lab spaces that I call it. Solar thermal. We have an off-grid cottage. We have other sites that we do work on. We show here Black Creek Pioneer Village, where we're evaluating a VRF system, solar, small wind, and we also have we do public tours, private tours. We have some meeting spaces, and we also do professional training in renewables, energy efficiency. Anyways, I'm going to stop shameless self-promoting what we do. Just a few links for you guys there. Whoops, I wanted to copy those. Actually, I think I had them copied. I'm going to put them in the chat as well. You guys will probably have this presentation for later. And I've rambled on forever. So let's see if there's any questions here.
That was great, Gil. No, you did not ramble on. That was very excellent information. And we do have a couple of questions from the later slides, so that's good. First question, can you elaborate a little more on gas absorption heat pumps?
Yeah,
yes, in
sure.
terms of what they are. And...
Yeah, sure. So a gas absorption heat pump is kind of similar to an air source heat pump. But the actual engine, so driving the compression and vaporization cycle, essentially the refrigerant cycle, is that driver is natural gas instead of electricity. There's still a tiny bit of electricity. That electricity ratio is maybe like, I don't know, 20 to 1 or something like that. Like there's still a tiny bit of electricity used, but you're essentially using gas to drive that refrigeration cycle, and it's in combination with kind of like an air source heat pump. So you're able to get gas efficiencies in the 100 plus. So a relevant number might be something like 110 or 115% natural gas efficiency. And again, you're able to do this because you're using that kind of outside air as well to move the energy around. So yeah, again, I wonder if I still have. Yes. Okay, this is a bit of a jumble, but I've put in the relevant links in the chat. Did I send it to everyone? Yeah,
yes,
and so.
Fantastic.
Yeah, okay, yeah. So if you look at that middle link, it'll take you to our main page. And we've got kind of two, usually on each technology we'll evaluate, we'll have 2 to 3 different types of reports that we put out. One is kind of like a very public facing 2 to 8 page brief. And then the other will be like a larger, usually 100 page plus technical evaluation. I hope that answers the question for the gas one. And again, the gas, so TAF has also done a really good gas absorption heat pump evaluation. And I think I might have included it there in the links as well. Yeah, I did.
Okay, fantastic.
Yeah, I hope that answered the question for.
Yeah, perfect. Thanks. One last question. We see that wind systems were mainly zero across the board. Is this due to land space limitations within municipal settings?
So there was actually one contract that was partially funded, but it actually failed. The wind turbine didn't fail, the design and the whole process kind of failed. So it was partly funded, but that funding kind of vaporized. No wind turbine emerged. I think at the time the industry was, I don't want to say at an infancy. Again, this is 2009, 2010. I think there was also apprehension on the technology and where to kind of place the technology. And the other thing, just anecdotally and what I've learned from wind is that, small to medium wind, even large wind, it's not really that suited for an urban environment. That is not to say that, some of these social housing providers, could have maybe invested in the wind and put it on some other chunk of land if they had a large piece of land. But I think there are probably some limitations, and I hope that answers the question there.
Fantastic. Yes, it does answer the question. That is great. So thank you so much, Gil. You've given folks a great overview of your programs and provided a lot of great references and resources for people to learn more. So we encourage everyone to check them out.